Hello everyone, welcome to this video. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to get a river level information from the Google Earth Engine code editor environment. In this tutorial, I'm going to show you how to get data from the SWOT satellite, one of the newest satellites launched in the remote sensing world. Allows you to get rivers and inland water level. That is very important data set, and also help you to get a lot of information and insights about the river's condition. So in the first step, I'm gonna show you how you can access to this data set. Actually, this data set not fully available in the Google Earth Engine platform, but thanks to awesome Google Earth Engine dataset catalog, it is now available for all of the user through the external links. So let's open a new tab on your browser and type Earth Engine, just like that. SWOT. SWOT is the name of the satellite that collects rivers level information and data. Here, as you can see, in the Google Earth Engine community catalog, there is a website here that allows you to get information about the SWOT river database information, and also what kind of information is available. Here you can see that you can have access to the rivers with greater than 30-meter widths for all of the world, and you will have a lot of information about the river's characteristic. And here there is a data table that most of the information introduced here. Through this data, you can have access to, for example, maximum flow accumulation for the river, and also the width of the river in different nodes, and the other information specifically about the average water surface elevation in each node. That is very valuable data set that allows you to get a lot of insight and information about the river condition. And here you can see the surface elevation, the width of the river, the slope of the river, and the other information listed here. They are available for the users that could help you for the hydrological modeling and do a lot of statistical analysis. And now I'm gonna show you how you can access to this dataset thanks to Google Earth Engine community data catalog. You can have access this data in the Earth Engine through the Earth Engine snippet already provided by the authors. Remember to cite this dataset and also this website if you are using this dataset for your own research work. So here the nodes and reach, both of them are available, and now you can copy and paste them into your code easily and without any challenge. This is one of the simplest tutorial, and also no need a lot of skills in working with Earth Engine. Only have a Google Earth Engine account is enough. So here you can see the nodes and also reaches. Both of them are merged version and available in all around the world. So first of all, try to select your own region of interest. For example, my own country, Iran, located in Middle East. I'm gonna select the region of interest as using drawing tools available here. Feel free to select your study area, your own study area. For example, if you are from China, pick a region from China. If you are from Algeria, pick a region from Algeria. If you are from United States, so select a region of interest there, because this data is available for all around the world and allows you to get a lot of information about the river greater than 30-meter widths. That is very beneficial for hydrological modeling. So now in the first step, I'm gonna actually clip the node data, included nodes and reaches and reach based on the region of interest or drawing tool. Here a new variable as node is created, but remember that this product is not as image collection. It has a vector structure and available in feature collection format here. So nodes equal to get the nodes merged before and filter it based on the region of interest already drawn by hand. So geometry, just like that, and make another variable reaches that merged dot filter bounds, again dot geometry. So as you can see here, both data, both variable filtered based on location of interest. To do the visualization, map.add layer allow us to visualize the nodes for whole of the Iran with a specific color, for example, or with a particular color. For example, I'm gonna show the nodes with the blue dots, and about the reach, I'm gonna show the reach lines with the red color, just like that. You don't need to be very skilled in the Earth Engine. This is one of the simplest tutorial and one of the simplest codes I'm sharing with you. Only call your desired data, filter it based on region of interest, and visualize it easily. So remember to save your code in your own Google Earth Engine scripts and try, and let's run again. So check it off for the geometry inputs, and now you can see the visualized data for all the rivers with greater than 30 meter widths. So, and here you can see the nodes and reach. For example, in the northwest of Iran, there is one region, and also this is one of the rivers in the northwest of Iran. And then here you can see, if you scroll down a bit here or zoom in the study area, you can see here we have Zarina route. Over the Zarina route, you can see the nodes every 200 meter spaced, and also you can see the reach as a red line here that segmented our study area based on different levels. Actually, you can monitor the water level, the water elevation every 200 meter. That is very beneficial and awesome for the hydrological studies, and you can actually get a lot of information about the river's condition every 200 meter over alongside the river lengths. So if you want to see what kind of information available here, just switch to inspector here and click on one of the nodes here. For example, there is a node and there is a line here. If you click on the node here, you can get two kind of information for the selected node. The first layer actually is a node information. For that point, you can see for the selected node, actually you can see here is WSE that shows the water elevation in this point, and also if the river's name is available, you can find it here. And the river width in this area is 108 meter. If you want to get detailed information about these properties available here, there are two kind of attributes here that allows you to get information. For example, based on this table of data, I understand that WSE stands for average surface elevation for each point or each reach, and also the unit is based on meters, or width refers to average width of each reach, and also the river in that point that is based on that the unit is also meter. And there are a lot of other information. For example, if you want to know about flow accumulation value for that node, it is a square kilometer. Here you can see, let's see, so FCC, let's see if there is such information for this area or not. Go to properties. FCC stands for flow accumulation, 10,480 square kilometer. It's a flow accumulation value for the selected point, and also you can get the slope for this area. And also, so if you go to the information here, you can get enough information about the slope property here. The slope stands for average slope of the ridge, calculated along the high resolution centerline points. This is based on the unit mentioned here, or distance from the river outlet to the ridge, and the other information, all of them available and explained very well for all the points. And imagine that you have such kind of data and information every 200-meter space. So let's zoom out a little bit, and also let me go to the upstream area here. If you check it on the train here, you can see that we are going from downstream, we are moving to the upstream, and now I'm gonna get information about the upstream here. Elevation increased in this region. Now while you are in the inspector, if you click on the point here, again 2 layers are available, definitely higher surface level expected here. The slope actually changed based on the located point, and the widths reduced in this region, and also the maximum widths also highlighted here. And the next one is WSE, that is 1360 meter above mean sea level. This is the water surface elevation, and flow accumulation also changed based on different physical characteristics that we have here. You can see there are a lot of information, useful information about the rivers that allows you actually to get a better insight about the river's condition. Now I'm gonna show you how to get export for your target river from the Earth Engine. Let's zoom out a little bit and actually limit your study area. So as you can see, I'm gonna select only one river located in northwest of Iran, or Zarine route here. So let's actually define your region of interest in a way, only Zarine route or the target river selected, just like that, and then try to get export using export.image to drive. Exports, sorry, this is not an image, this is a table, table.to-drive. Make a curve bracket here, inside couple of arguments necessary. The collection related to the feature you want to get export. For example, if you want to get export from the nodes, the collection is nodes. Otherwise, you must pick the ridge. And the next is about the description. Description equals to the nodes, for example, nodes for Zarine route. And then the next one is the description and the folder, the target folder. If you want to save your data in a particular folder, feel free to make a new folder. For example, I'm gonna save it into the test folder. And the file format is another important thing. File format equals to SHP or shapefile. Okay. And another table, you can have 2 kind of export, one of them for nodes and the other one for ridge. Ridge has line format and node has point formats. So description, this is ridge data for Zarine route, and remember to save your data and run it again. After a few moments, you can see the nodes and ridge data for Zarine route. Just click on run again. After a few minutes, typically less than 1 minute, same as previous example, the process of saving is over and turn to the blue color. And once the tabs color turn to the blue, feel free to pick it up from your Google Drive. But previously, I did this for my region of interest, and now I'm gonna open it up into QGIS software. If you are using QGIS or ArcGIS, no matter, only a geospatial software is needed, allows you to launch or call Esri shapefiles data. So here, for example, ridge and nodes already downloaded for my region of interest, and here you can see the nodes available in different formats, DBF, PRJ, SHP. As we are working with the SHP, just pick the SHP here, click on open and click on add here. So as you can see, only for the selected area, the points extracted here, But here, if you go to the attribute table, there are a lot of information already I explained you, helps you to do a very popular visualization that gets more understanding about water surface elevation changes over the river from upstream to downstream here. So now I'm gonna actually do some sort of visualization. We need to have access to the Symbology. Just go to the properties, and in the Symbology tab, try to find the graduated color, and then select your target field. That here is WSE, that shows the river elevation, river water elevation in different points for every 200 meter distance. WSE is available. Let's classify the value in different colors. I prefer to use different color tables, for example the spectral here, and then click on apply and then OK. Zoom out for your, or right click on the data and go to the layer. Here you can see the color variations that shows the different water levels from the upstream with more water levels to the downstream with lower water levels, that you can see here how the elevation, how the water elevation, water surface elevation actually changes from up to down. As you can see here, it is very interesting things, interesting data set with a lot of information. I'm not a hydrologist, but for those who are hydrologists, such kind of data is a valuable asset, enables them to get a lot of information about the river's condition. So we can do the same process even with the other layer that is available as a rich or line formats. So let's add it into your software. You can see it has a line format. Feel free to go to the Symbology and select the graduated and pick the WSE, change the color same as before, and do the classification for the region of interest. It is better to increase the line widths here. For example, I'm gonna increase it to 1 for each segment actually, or for each class. So here, let's try for all segments, and here it is. Click on OK again, OK, and OK. And here you can see the same variation but in a line format. You know, it is very interesting things, and you can do a lot of visualization based on different information available in the attribute table. I showed you a lookup table, helped you to understand, or you can actually classify the river widths or maximum widths in different segments based on values we have here. It is also very useful things for a visual for the river widths visualization that could be very beneficial in hydrological studies. I hope you liked this tutorial, and feel free to reach me out on my YouTube channel. Put your comments there. I will try to check and answer the comments as soon as possible. Thank you for your attention.